Hello, welcome everyone to another session of Current Affairs by Series 360 IAS Academy. In this session, we will be discussing about the recently passed Shanti Bill, which tries to to improve upon the nuclear energy regime in India, right? So the Shanti Bill, which is essentially short for Sustainable Harnessing and Advancement of Nuclear Energy for Transforming India Act. It is now an act. It actually repeals the Atomic Energy Act of 1962 as well as the Civil Liability for Nuclear Damage Act of 2010 as well as the rules and regulations that actually came under them. So let's see why this act was passed, what are the important provisions of this act, and what was the changes from the earlier nuclear energy regime. Okay. So it was actually introduced by the Department of Atomic Energy. If you know about the Department of Atomic Energy, it is directly under the Prime Minister's office. It is directly under his control, operational control, and that department actually introduced the bill, Sustainable Harnessing and Advancement of Nuclear Technology for Nuclear Energy for Transforming India, right? So Shanti Bill, right? So let's see so whenever you study about nuclear energy, it is part of GS3. You have energy. There is a separate topic is there. It can also be asked in science and technology perspective, but it is more there is a more probability that it can be asked in the GS3 economy part. Okay, and also there is sometimes there is a chance for it to be asked in GS2 where governance aspect is there, but there is a small that's a small possibility. Large possibility is that it will be asked under GS3 economy syllabus under energy infrastructure, right? So to talk about the nuclear energy, first you need to know about the current status of nuclear energy in India, right? So you need to know about the current capacity, current generation, okay, and what are the targets. So difference between generation and capacity, I hope that is clear to you. Like for example, capacity actually refers to the how much the potential, okay, the capacity of particular energy means the maximum potential a particular a country or a particular entity can actually create, right? So there's a difference between capacity and generation. So India, as of now, the capacity is close to 8.8 gigawatts. Okay, 8.8 of gigawatts is being nuclear energy is 8.8 gigawatts. India actually has the capacity to produce up to 8.8. Okay, this is the maximum capacity, 8.8 gigawatts. But the problem is the actual generation. Okay, the generation of nuclear energy is actually less. That is the energy that is met according to the demand. Okay, according to the demand, only 3%. Okay, only 3% of the electricity generated as per the demand of India is actually met by nuclear energy. Okay, so imagine there is a nuclear reactor. Okay, imagine there is a nuclear reactor. Say it has the ability to produce 2 gigawatts. Okay, 2 gigawatts is its capacity. Okay, that is the maximum it can produce. But say there is a small town. Okay, there is a small town, and it actually demands like about 1000 megawatts or 1 gigawatt, right? 1 gigawatt. Okay, so this is the actual generation. Okay, only 1 gigawatt is being generated by this, and if this 1 gigawatt is met by that nuclear reactor, it simply means okay, that nuclear reactor is meeting the 1 gigawatt only, right? But the capacity is there, but that is not needed. Okay, only the capacity is there. Okay, so that is the difference between capacity. The same goes for any type of energy. Okay, so please keep that in mind, right? And if you look at India's nationally determined contribution targets, most of them is regarding capacity. Okay, because it is easier to do. Okay, so as of now, like 70% of our electricity or energy needs is being generated through coal. Okay, it's fossil fuel based. There are a number of reasons regarding that because of the base load generation capacity. There's another concept known as base load. Right. So base load means that the most, what you can say, the minimal demand that will be there in the grid. Okay, so those kind of needs, okay, that quantity of energy that a grid particularly demands as the most minimum is actually the base load, right? So for meeting that amount, you need fossil fuels. Okay, you need fossil fuels because you can easily improve the inventory, you can easily improve the capacity, okay, and meet that generator, the required electricity need. Okay, so to meet the base load, renewable energy like solar and wind is not less useful. Okay, that is because say for a month, okay, March 2025, it is summer season, right? It is summer season, so the base load in a particular grid will increase, right? Okay, the energy that is being demanded is going to increase because of cooling needs, right? So suddenly say 100 gigawatts, okay, was there in March, it shot up to say 200 gigawatts. Okay, so now the base load is 200 gigawatts. Okay, you need to meet 200 gigawatts. So if you have solar and wind, it's not easy to ramp up your generation, okay, because they are intermittent. You need a lot of storage infrastructure, okay, so a lot of issues are there for solar and wind kind of like energies, right? But coal is enough. Okay, fossil fuel, you just need to improve the supply. Okay, so if you get more coal, you can put it into the thermal power plant and generate more electricity to meet the need easily. It can be done faster. Okay, so there is a easier way. The fossil fuels are easier to ramp up your electricity generation, right? But nuclear energy can also do this. Okay, that is another advantage of nuclear energy as a renewable energy, as well as meeting the base load capacity. So this is another advantage for nuclear energy. Okay, because nuclear energy, you have that capacity, you have that excess capacity, so you just need to improve the plant operations, or you can just add one more unit to one more reactor to the production. Okay, so that is another advantage of nuclear energy. I hope this concept is also clear. The base load concept is also clear, right? So nuclear energy is actually fitting all the boxes. Okay, it is allowing us to ramp up our grid capacity, base load, to meet the sudden demand. Okay, and also but the problem is, as of now, India is 70% of our electricity is generated is from the demand is met by fossil fuel. Okay, 70%, right? So only 3% is from nuclear energy, right? And India's target is 100 gigawatt capacity. Okay, capacity by 2047. Sometimes UPSC may ask 100 gigawatt generation by 2047. No, it is not generation, it is only capacity. So please keep that in mind. 100 gigawatt capacity is our target by 2047. Okay, so these are the different type of activities involved in a nuclear energy chain. Exploration of the atomic minerals, which involves mining and all those things. Fuel fabrication, which includes centrifugal, that is, you are actually separating the uranium 235, right? Uranium 235 is the isotope that you need, right, to generate nuclear energy. So uranium 238 is the one that you occurs naturally in nature, right? So then you have equipment manufacturing, and then you have plant operations, right? So basically there are different parties involved, but broadly it can be divided into suppliers of equipments as well as operators. Okay, so the operator as of now is the Nuclear Power Corporation of India, right? Nuclear Power Corporation of India Limited, NPCIL, right? So this is a state-owned entity, and nuclear energy regime as of now, before Shanti Act, do not allow private operators. Okay, do not allow private operators, and only a state-owned operator is there. Suppliers could be private. Okay, suppliers could be private, but only a state-owned operator can actually run a nuclear power plant, right? Okay, so that is an operator and supplier. Okay, now reasons for reforms. This is also important. It can be asked for a mains perspective, okay, and also it could be asked in prelims, okay, like we will see one question. But just to give you a broader context, before the Shanti Act, our nuclear energy governance or regime is governed by the Atomic Energy Act of 1962 as well as the Civil Liability for Nuclear Damage Act of 2010, right? So there are a few points regarding that. The first important point is regarding the liability. Okay. Okay, so nuclear energy regime as of now, the first important point is Okay, first I will just start off with participation of private sector. Okay, as of now, who can operate? Operators. Okay, operators. There is only one operator, state-owned operator, Nuclear Power Corporation of India. They operate the nuclear power plant. Although the suppliers could be different, the operation is done by only a state-owned entity. Okay, and second point is regarding the liability in case of something happens. Okay, nuclear damage, nuclear energy, it escapes and it causes damage. There is a no fault liability. In legal terms, it's called a strict liability. Okay, strict liability. So liability. Okay, liability is another thing you have to remember in the existing atomic energy regime. Third point is regarding the regulator. Regulator as of now is, before the Shanti Act, it is actually Atomic Energy Regulatory Board, which is a kind of like a legal body, but its powers are actually derived from various legislations. Okay, Atomic Energy Act, Environment Protection Act. Okay, so it gets powers from different legislations. Shanti Act actually changes this and gives it unified autonomy. Okay, it gives it lot of powers, lot of regulatory powers. Okay, that is also another change. Regulator. Okay, and then dispute. Okay, disputes. So dispute settlement in the earlier nuclear energy regime was through general courts. You have any problem, you come to a general court. But Shanti Act, it creates dedicated nuclear energy redressal advisory councils. Okay, nuclear energy, atomic energy, not atomic energy redress advisory councils, as well as appellate mechanisms. Okay, these are all being created by Shanti Act. So that is another thing you can have. So these four headings or four areas have been changed by Shanti Act. Okay, not just four, there is a lot of other changes, but these four are the things you have to keep in mind. Okay, so let's look at one by one, or how the nuclear energy governance regime was before Shanti Act and how it is going to change under the Shanti Act. Okay. So the first one was operators. It was pretty simple. Earlier, only one operator. Now it allows private participation. Okay. Now any private party can actually operate nuclear power plants in India after the Shanti Act. Okay. So I hope that is clear. It's pretty straightforward, right? Okay. Okay. Then it's regarding liability. So liability under the previous nuclear governance regime, like I said, there was strict liability, which is also called no-fault liability, as well as right to recourse. Okay, so two things we have to remember. Earlier nuclear, so if I am actually, so imagine I am the Nuclear Power Corporation of India, I actually run a power plant, right? Something happens, okay, some gas leak or explosion happens, it causes damage. I have no escape clause. Okay, the operator have no escape clause. That is what we call as strict liability. Okay, strict liability. There's also a concept of absolute liability, but don't need to go into all those things. No fault liability. Whatever, I cannot take any defense. Okay, I cannot take any defense. I have to give, under the earlier nuclear governance regime, it was 1,500 crore. 1,500 crore. This is for large nuclear power plants. Large nuclear power plants are those with capacity of greater than 3,600 megawatts. Okay, or 3.6 gigawatts anyway. So, so just don't need to go into that much technical details. But just remember 1,500 crore. I have to give this 1,500 crore. Okay, and if the liability, the damage cost increases beyond that, okay, increases beyond that, then the government will step in, and the government has secondary liability, and that is up to 300 million special drawing rights. Okay, the value of 300 million special drawing rights of IMF. Okay, that value would be covered, up to that value will be covered by the government. Okay, so government has secondary liability. Okay, and if the damage is again exceeding beyond that, then there is a convention on supplementary damage of nuclear energy. There is a convention, and India can access the funds provided under that convention. Okay, if it exceeds the value of 300 million special drawing rights. So this is how liability used to flow in the earlier nuclear governance regime. Okay, that is one part. The next part is the right to recourse. So in the earlier nuclear governance regime, so if I am NPCIL and I will pay 1,500. Say the damage cost is 1,000 crore. Okay, up to 1,500 crore I have to give. This 1,000 crore that I paid as compensation, I have a right to recourse. I have a right to recoup that from the supplier. Okay, supplier, in case or if there are 3 conditions where that happens. One, the supplier who actually supplied me with the equipment or the the fuel or anything, they have an agreement with me, a specific agreement, and in that agreement there is a specific provision that allows me to claim compensation. Okay, another is if that damage was actually caused due to the some issues regarding the equipment that was supplied. Okay, and third, if the so there are basically like I said 3 conditions, like for example like I said, if the contract specifies that if the equipment has any damage, as well as there was an intention, okay, there was an ill intention from the supplier to actually cause the damage. Okay, so these 3 criteria are there which allows the operator to claim compensation from the supplier, which is known as the right to recourse. It was under the earlier nuclear governance regime, but in today's or the Shanti Act tweaks this a little bit. Okay, tweaks this a little bit. It says the right to recourse exists, but only if the contract specifies for it, or if there is a clear-cut intention from the supplier to cause nuclear damage. Okay, if that is proved, okay, then you can claim the compensation. Okay, but the important ground where that equipment is defective, okay, equipment is defective and supplier liability will come, that has been taken away. That is a most significant change in the Shanti Act. This was a sticking point between Westinghouse, several nuclear power companies are there in US, France. Why they were hesitant to come to India to build power plants or supply the equipment material is because of this clause. This was in Civil Liability for Nuclear Damage Act of 2010, but that sub clause has been removed. Okay, so one small part. What is the part that the Shanti Act actually removes? That the operator can claim recourse from the supplier if the equipment supplied from them has been defective and which actually caused that nuclear damage. Okay, there is no more, that ground is no longer there for the operator to claim the compensation from supplier. So I hope that is clear. Okay, but the other part, so after the liabilities, everything has been retained. The operator has a strict liability and it has increased the quantum to 3,000 crore. Okay, it has increased the quantum to 3,000 crore for larger power plants. For less power plants between 1,500 megawatts to 3,600 megawatts, it is like 1,500 crore, and then it has reduced amounts like that. But rest of all the things are retained. But the key sticking point for the foreign players have been removed. Okay, I hope this is also clear. So that is regarding the liability. Regarding the regulator, like I said, the Atomic Energy Regulatory Board has got exclusive power. It is now a completely autonomous statutory body under the Act, under the Shanti Act. Right. Dispute settlement, I mentioned a Nuclear Energy Advisory Redressal Council has been established. Appellate mechanisms are also going to be established. So a dedicated tribunal to fast track, grievance redressal is also there. Okay, so now that is the gist of the Act. Okay, now I'll just explain, just give a summary. These are the reasons for reforms which sometimes they can ask for mains. So if you look at that, the operational reason is there, right? Like I said, base load alternatives, the concept of base load, right? So nuclear energy, we need nuclear energy should be part of our future, right? To meet our NDCs, to achieve net zero by 2070 and all those things, right? So base load alternative coal-fired capacity tide over the limitations of renewables. Okay, this is, I hope I explained it earlier, right? Investments, need for capital. Okay, so we need large capital to build the infrastructure. We need foreign capital. Okay, to attract the foreign players, we needed to remove that supplier liability sticking point, right? So that is also there. Technological, we actually use the pressurized heavy water reactor, but that is pretty, what you can say, a little outdated, because the world has now moved on to light water. Okay, light water, where you use light water, we use heavy water, which is deuterium, right? They use light water, and light water is used as moderator and everything. These are the plans in the Western countries. They use light water, right? So to get that technology, okay, we need to attract foreign private participation, right? That is why. Okay, so okay, and also to attract for small modular reactor. India government is trying to push for small modular reactor as a, India as a hub for that, its manufacturing and everything, and this also suits our needs. It produces up to 300 megawatt. Okay, okay, and it's a recycle fuel. Time taken to refuel. Okay, that is also advantageous. So small modular reactors as another topic, but it has several advantages. To attract investment into the SMR, you needed to reform the nuclear energy governance regime. Okay, legal, right to recourse, okay, which is what I mentioned, and the Atomic Energy Act, okay, which excludes private sector participation, which also I mentioned, right? Okay, so this is just the summary. Okay, so you can understand it's pretty straightforward, right? Okay, it's pretty straightforward. You can see the existing regime here. Legal structure, you have multiple rules, multiple regulations. It consolidates everything, right? So this is an important change. It repeals the Atomic Energy Act. It repeals the Civil Liability for Nuclear Damage Act. Ownership, okay, earlier only NPCIL could operate. Here now private sectors now can operate. It promotes FDI up to 49%. Okay. Regulatory architecture, Atomic Energy Regulatory Board, but Atomic Energy Regulatory Board got its powers under an executive order of the president. Okay, ERB, although the AERB exercises functions as per the Atomic Energy Act, it was actually constituted by the president by an executive order. So it is kind of like statutory, but it has powers derived from that executive order, right? But Shanti Act creates AERB as a separate legal regulator. Okay, that is, its name is mentioned in the act. Okay, so it gives it autonomy and all these responsibilities. Now licensing, we can see multiple licenses were there. Here it is in a unified licensing. Okay, unified licensing, which is something government is trying to do in various sectors. Okay, so they may say compare and contrast the nuclear governance regime, okay, and the governance regime under Shanti Act. Okay, they can ask. So please be ready for those kind of comparison, right? This is the most important change. Liability regime, who pays for the nuclear damage. So I explained about the no fault liability for operators, okay, up to 1000 crore. Okay, earlier it was 1000 crore and up to 300 million special drawing rights. If the amount goes beyond that, that is for government. Okay, that is a secondary liability. Okay, and if the damage exceed again beyond that 300 million SDR, it will be covered under the Convention on Supplementary Compensation. Okay, so these kind of provisions are retained in Shanti Act. Okay, they just improved the limit of 1000 crore to 3000 crore, only change. But the supplier liability of the right of recourse has been tweaked. Okay. Okay, so earlier they could get get the repaid. Once again, just to summarize, three grounds are there. What are the three grounds? If the contract mentions it, if the equipment has been damaged, if there was an ill intention, okay, from the supplier to cause nuclear damage. Okay, now that equipment is defective, that provision, okay, of the earlier civil liability for nuclear damage must be removed. Okay, so it replaces CLD up to 3000 crore, removes a limit supplier liability, narrows the right of recourse. Right of recourse is for the operator. Okay, okay, only when it's expressly provided in the written contract or when the incident is due to an act or omission with the intent to cause nuclear damage. Right. So I hope that is also clear. Right. Then strategic fuel cycle. Okay, this is another important point. The strategic fuel cycle regarding the security, right? Waste management. Okay, these kind of enrichment, material control. These are all under state control. Okay, that is being retained. Okay, that is being retained. Okay, that is to ensure that Fukushima aspect or the Chernobyl or the 3 Mile Island disasters, so those kind of disasters do not repeat. Okay, so safety has been reinforced, okay, and enforced. Dispute resolution, general courts, now they have a separate tribunal council, atomic energy grievance redressal council, advisory redressal councils. Okay. Now let's look at a sample question. This is basically the gist of the change. India's nuclear liability regime has moved towards limiting supplier liability in order to encourage foreign and private participation. It's correct. Statement 2. Under the earlier nuclear energy regime, suppliers could be exposed to broader liability for nuclear damage through provisions of civil liability law. Yes. The present framework places the primary liability for nuclear damage on the operator of a nuclear installation. Correct. Okay. So both these are correct, and this explains statement 1. It's actually A. Okay, so this is basically the gist of the change that has been brought in. Okay, I hope this topic is clear. Thank you.